It's Infrastructure Week on the Daily Blog, and today we're talking about mesh networking. I want to explain what it is and why it's important. But first, if you need a quick refresher on the basics of WebRTC networking, check out this intro video linked below. So let's talk about mesh networking and why you should care. If you're building a product with video calling or you're using a video calling service, you probably care about call quality quite a bit. You want calls to look their best and sound their best and not drop out all the time. You want to feel like you're actually talking to another human instead of stepping on the beginning and end of every sentence. Mesh networking actually helps with all of that. So let's start with Alice and Bob, who want to have a call with each other. Now, in some circumstances, they'll use a direct peer-to-peer connection with each other like this. But nowadays, most of the more interesting use cases, like large calls or cloud recording, actually involve making those same peer-to-peer connections with some kind of server, like this. This is even more important when Charlie and Deborah join the call, because now, instead of everyone having to connect to everyone, each person only has one set of connections with the server. The server can choose to forward different tracks to different people, or send different video quality to different people based on their connection speed. But what happens when we put an ocean between Alice and Bob down here and Charlie and Deborah up here? Well, sadly, I don't think AWS is doing an Atlantic Ocean 1 region anytime soon, so we're just going to have to pick a side for the server and put it somewhere. We'll put it by Charlie and Deborah up here. We'll call this the US side. This works okay, but latency becomes an issue, especially for Alice and Bob. Last week they were doing that peer-to-peer call from the first drawing where they could connect to each other directly. But now, even if Alice and Bob are in the same office building in London, Alice's media has to travel all the way across the ocean to the server up here, and then all the way back down to Bob to get to his screen. It'll still feel close enough to real time, but it's a little bit worse than it was before. And you can see how this gets even worse when you have Aaron join from South Africa and Frank from Taiwan. Their connections have to go through a lot of internet to get to the server up here on the US East Coast. So what if instead we keep our server here in the US, but we add a server down here in Europe and another here in Africa and one here in Taiwan? This map is definitely not to scale. Now, each person has a much shorter path to a call server, which means lower latency and more reliability. Of course, this is pointless as it exists right now, because only Alice and Bob can see each other, and only Charlie and Deborah over here and Aaron and Frank are just both talking to themselves. As you might suspect, that's where the global mesh network part of this whole thing comes in. What if we connect all the servers directly to each other? It almost kind of looks like the peer-to-peer drawing from before, but these links are using a robust, dedicated, low-latency connection to move media back and forth between the servers. This can end up making the call experience better for everyone for a few different reasons. But those reasons can all pretty much be summed up in one word: consistency. Consistency means a few different things here. The first is overall reliability. These parts of the picture out here are where things like people's home internet and Wi-Fi routers come into play. Because WebRTC prefers to move media packets through UDP when it can, packet loss can be a concern. And in general, the further you need to move a UDP packet over the open internet, the more likely you are to experience packet loss here and there. So keeping these parts short keeps them more reliable. But latency is also really important. In fact, we'll have a lot more to say about latency in another video, but today, we're more concerned with the variability of latency, which is a number called jitter. Sometimes one packet being sent through one of these connections out here might take 20 milliseconds to get from here to here, but the next one might take 80 milliseconds. If there's a lot of jitter back and forth out here, this client has to keep a bigger buffer to compensate, and a bigger buffer means more delay. These mesh connections have much lower jitter. As a result, they can provide a more consistent way to send media out to all of these participants. So even if it sometimes looks like a longer path on paper to go to a server and back, rather than connect directly peer-to-peer, the consistency of the mesh connections often means that the resulting experience is better. It's like driving on interstates rather than sticking to neighborhood roads, or better yet, it's like taking high-speed rail instead of sitting in traffic jams. The other thing that mesh gets you is scale. Let's say that each of these servers here is able to manage connections for 500 users. If your call has to be contained to a single server, that means you're limited to 500 people on that call. But if multiple servers can talk to each other and share the workload for a single call, it opens up a lot of interesting architecture possibilities to scale way beyond 500 people. We have a lot more detail about how that works in this blog post. Scaling WebRTC calls to tens of thousands or hundreds of thousands of participants is really hard and pretty much impossible without mesh networking. We'll have more to say about that in another video coming soon.